Welcome back. In the last video, I made a scatter plot for some of my mountain bike rides, and I estimated a line through there. This is my estimate of what we call a line of best fit, or a trend line. So what I'm going to do next is I'm going to try to find the equation for this trend line. So that's the topic right now. Equation of a trend line. And first we'll do it the old school method where we pick 2 points that the line passes through and we find the equation through those 2 points. The equation that we're going for is your standard equation of a line, y equals m times x, that's a little times there, plus b. M is the slope, and slope is the rise over the run. And b is known as the y-intercept, and that's where the line would hit the axis. Intercept. So we can kind of estimate if we pull that line through a little farther. Looks like it's going to hit around 2-ish for the y-intercept. For the slope, we got to find, to get, say, from this point to that point, how far do we go up and how far do we go over? So we got to go from here up to there-ish, and then from there over to here. So what is that rise there? What is this run? So we'll calculate those values. So calculation. So usually I do the slope first. Oops, that is not a pen. Let's switch to blue. And for the slope, I'm going to start off by finding the rise. And so the rise is I'm trying to get from that 7.69 number here up to that 15.5 number up there. So what is 15.5 minus 7.69? And so we whip out our favorite calculator. And I need a calculator screen. Let's grab this. Oh, we might as well do it in here. Slope is rise. Let's blow that up. And the rise, I can just say, hey, what is this number minus this number? And the computer says it's 7.46. And I think I grabbed the right numbers there. Yep. Okay. So let's see, we can leave you here and go back there. 7.46, is that what I said? Yep. All right, and then we got to find the run. So let's write this down. Rise is 7.46, and then the run. And the run is going to be the time. So the time down here was about 0.93, and the time over here is 2.13, which is about over here-ish. So what is 2.13 minus 0.93? And so we could check that on a calculator. Run equals 2.13 minus 0.93. And I'm actually typing the numbers this time because I have slightly different versions of them up there. I get 1.2 if I did that right. Does that look, oops, there we go. Does that seem about right? Yeah, that does seem about right. 1.2. And the slope is just dividing these two. So if we throw a little division bar, rise divided by run, the slope is going to be whatever that fraction is. So ask my computer again. Lost my computer, there you are. So the slope equals this number here divided by that number there. And you don't have to use a spreadsheet for this, you could use a regular calculator. So hopefully that works out okay. So if we're going to round this, let's say to 2 decimal places, it would be 6.22. And I'll do this in another way with a calculator in a sec. So 6.22-ish is my slope. Slope is about 6.22. Now, slope, what does it mean? Again, it's rise, so that's miles divided by run, which is hours. So this would be miles per hour. So that's kind of an average speed in this case. So we could say that is Gary's average speed. So I'm just going to double check that again. So slope, another way to get slope is a lot of times people are used to the equation y2 minus y1 over x2 minus x1. And if we plug that into a calculator, we want parentheses around numerator and denominator. So I'm going to attempt to type that in to my calculator. So let's just bring up the Google calculator. So I want parentheses 15.5 minus 7. I think it was 69. Let's see. Yep. And then divide by parentheses 2.13 minus 0.93. Close parentheses. And, oh shit, I got a different number. So what did I type wrong? Let's see. It's good to double check stuff. 15.15. Oh, okay. So I just miswrote something somewhere. 15.5 is what I wrote there, and my spreadsheet shows 15.15. Okay, so I mistyped things on paper compared to my spreadsheet. Good to know. You ever miscopy anything? Happens to me too. Okay, so this was a typo compared to my spreadsheet. And so if I adjust that first calculation, I should get more like 6.5. So let's double check. That would be right here. So instead of using the spreadsheet numbers, which are different because I miscopied, I'm going to go with what's written in my notebook. So 15.5 minus 7.69. That gives me 6.508, and Google says 6.508. OK, so we're going to go with that slope instead, even though the spreadsheet one, I think, was what my bike computer said, but that's OK. It's the idea that matters. So that is a different number, and this eraser should be 6.51 if we go with the number on the screen here. So 6.51, and what did the computer say that was? Oh, where'd you go? Hello? Oh, I moved it over there. 7.81. Let's bring you back here. And here. OK, so 7.81 was the recalculated number. All right, so not too much different. 6.2, 6.5. It's a little over 6 miles per hour is Gary's average speed. Mountain bike rides I do a lot of uphill climbing, so it's pretty slow. So that's the speed. So I have the M right now here. I got to find the B. So new page. The way to do that is I know I want y equals mx plus b. I just calculated m to be 6.51 approximately. I don't know b yet, but I do have choices for x and y. So back here, I can either pick the first point or the second point. I'm going to go for the second point. So I plug this in for x and that in for y. So y is 7.69 when the x value is 0.93. And now I can solve for b by multiplying these suckers together and then subtracting them over. So what is that multiplication? Calculator, please. There you are. Get up there. OK, so I'm going to take my 6.51 rounded slope, multiply by my time of 0.93 hours, and that gives me 6.0543. So I write that in here. So this is 6.0543 plus B equals 7.69. Next thing we do is we subtract that over, and voila, we have B. And calculator time. There you are. So I want 7.69 minus 5, no, was it 6.0543. And I get about 1.64 if I round it to 2 decimal places, which on my screen I think is more than good enough. Let's see, what did I say again? 1.64. So subtracting gives me about 1.64. On this, those are 0, so that's my B. So now I think I have an equation. I think that line on the other page is about approximately y equals 6.51 miles per hour times the time I rode plus a little fudge factor of 1.64. Now what does that number mean right there? Well, that number, if you plugged in x equals 0, then you would get y equals 1.64, right? So that's the point, 0, 1.64. So the y-intercept is a point. In this case, the 0 is hours, right? That's my x, and this is miles. So this point says if I don't bike any hours, no time biking, I've already covered 1.5 miles. It's useful in terms of finding this line, but it's not meaningful in terms of reality, because that's not possible. You can't not spend no time and cover that much distance. But it gives me this line right here. The y-intercept should be 0. If I don't bike any distance, I should have 0 miles. All right, so I found that line right there. I'm going to ask the computer to find it, and that does it a little bit different. So computer. So earlier I asked, in the last video, I asked the computer to find a scatter plot. And it turns out I can edit this chart. And so in Google Sheets, what I do is I click on the chart and then the edit, and then I switch from setup to customize. And then the series are the points. And what I want to do is add a trend line. And then Google says, yeah, I can find a trend line. Excel will do this also. It did pick this point right here, which is interesting, but it didn't quite pick the last point. It said it should be a little higher up to split the difference. And this is a line of best fit. It's called a linear regression line. And the goal of the linear regression line is to minimize the total distance between the points and the line if they don't hit each other. So this is like the best line possible to go through these points to get as close to all of them on average. To see the equation for the line, I have to hit another button. So customize series. After you turn the trend line on, you want to label it with the equation. And so the computer says Gary's average speed was more like 7 miles per hour and with a y-intercept of 1.35. Now again, this y-intercept is kind of meaningless because that says if he bikes for no time, he covers a mile and a third. So that's nonsense. But the average speed is meaningful. So on average, when I do mountain bike rides, I think most of these rides are on the Pendleton trails, which have a lot of uphill climbing. I do about 7 miles per hour. So that's a trend line to go with a scatter plot if the scatter plot appears linear. Now keep in mind, not all scatter plots are linear. So I'm sure you've all been checking out the COVID-19 stuff. Let's see, how do I spell worldometers? Okay, a place called Worldometers has been keeping track of cases and deaths and so on. And these are points, the number of cases per day throughout the world. Notice these points clearly do not line up. So to put a line through these points would be nonsense. So although I can make a scatter plot for lots of bivariate data, they don't always line up. When they do, we can try and find a line. And I just showed two different techniques. Have fun, do good math, stay safe, bye.